Hello guys, in this tutorial we are going to see two things. One is how to check the block's health status, and also I will show you how to use the AIOS's streaming facility via WebSockets. Streaming is useful in case of LLM model kind of inferences, right? So for that reason we will show a quick demo on that as well. So uh, basically the health check are nothing but to understand the model's health status, like what is the last time it has received any health metrics kind of things. So here we have basically uh, we are covering three things. One is the basic health check, how to do the health check, and understanding the health check status, and also I will point to the right documentation where you can come up with your own health check policies. So the health check API goes like this. We have the metric service API, we have the port, and the block is the endpoint, block health is the endpoint, and we need to provide the block ID. So already I have this particular Magistral small 2506 Llama CPP block is up and running. So we'll check the health status of it. So here basically I'm using the request API, request library to do this request inference. Like you can see, I'm passing the URL. I'm doing request.get to get the to call the API and raising the status here. So let me show that. Yeah, now you can see that under this block ID there are two instances. One is the executor, which always comes by default, and its health status is also true. And then we have this instance, right, the actual model, where you can see its last metrics is received like 25 seconds back, and the success is true because that is their API response, right? So in this health status, basically we will get the block ID, the healthy status. This healthy status is based on both the the executor and the instance status, and there are multiple instances. Accordingly, this will have a different value. And let me just yeah, now I just ran again. Now you can see the last metrics is received 15 seconds back, right? So I think it gets refreshed every the metrics are added every 30 seconds. That's why we are seeing the last metrics now and again. Even if I run it again now, yeah, you can see 2 seconds before, right? And for more information related to the health check related things, before that, let's understand why health checks are needed, right? So health checks are needed to understand the block's stability and all. So if the GPU temperature is high, or we are logging specific log messages, and the age of the last processed request, maybe these are some of the heuristics or hints to that gives us some kind of information about the block's health status, right? For more information, I request you to check this documentation. It has a detailed explanation about how to implement your own health check kind of policies, right? How the management methods are required to be defined, and how the eval methods, what it receives as input and what you have to send it as output. All those things are covered in the documentation. Now let's move on to the streaming tutorial. So first of all, we have this a thing about LLM where we can get the streaming output from the LLM model. We need not wait for the full output generation text to come. We can wait for we can even receive the streaming data, like how the model is thinking, or as it generates each and every token of the final output, that also we can get. So for that reason, we are showing this demo, and this will also in case of chat experience, chat application kind of things, this will give a real-time feel to the user as well, right? So we will show how to do a real-time WebSocket based communication. And again, we are also using a session-based streaming, right, for maintaining the conversation context. And we will also show how to access the streaming data and like a normal Python kind of access, and also we'll show a UI-based demo. And in the Python kind of data, we will show like asynchronous request will happen. It will wait for the the streaming data to come, and we will display the streaming data. Right. So here the prerequisite is we need to keep the one model up and running that supports the streaming facilities. So here for the tutorial we have this magistral small 2506 llama CPP block. I just now showed like the model is up and running, right? So I can again check the health status here. Yeah, you can see it got the last metric around 21 seconds back, right? So for this tutorial, actually, we'll be showing it in two notebooks. One is this notebook, which highlights how the Python's streaming facility we are using, especially WebSocket related things and AIOS related things, and to do an inference and to get the response, right? For that, we have I have opened another tab here and this Jupyter notebook, where we need to paste the session ID and the block ID to do the inference, which I will show in some time. So here, let's first install the necessary dependencies, and then we'll go step by step. Yeah, the required packages are installed and configured. So let me, so here, since we are interested in the magistral small block, I'm passing the block ID, and the AIOS management API is this, right? Execute management command. It has this endpoint and API endpoint, and the inference API is also given. We will see where, which is what what is used in the other places. So the block ID I'm assigning, and in the session ID I'm doing a UID based session ID. So let me run this. Yeah, so it has generated a session ID. Now what we have to do is we have to enable the streaming for this particular block. So for that, what we are going to do is we are going to use the executor, and we are going to pass this command, enable streaming command, to the executor. So this is a management command with which we will actually get a block that will have the streaming capability. So here we'll pass the block ID and the executor service and the enable streaming command. So let me run it now. Yeah, now you can see it is saying the streaming is enabled, the success, the response status is true. Now, now the block has the streaming capacity. Next thing that we need to do is we need to get the WebSocket's, the streaming URL. So for that, again, we have a endpoint. The service is the executor, but the management command is get streaming URL. So basically, we will pass the block ID to this service executor, and we'll get the streaming URL. So let us do that now. So this will be the WebSocket URL, which we will consume to integrate with the UI or other things, where we can get the streaming response. So let me run this. So yeah, we have got the streaming URL here in this WebSocket connection, in this port and IP. So now it is assigned to this WebSocket URL variable as well. So next thing that we will do is we will do an actual the connection test. So now we will do a actual WebSocket connection test. We have this WebSocket URL now. Now in this step we will actually test this streaming functionality, right? So what we are doing is we are basically establishing the connection with the WebSocket URL we got, and we are using the session ID that we got here, right? Yeah, this is the session ID that got generated. So we'll be using this to connect with the WebSocket, and we will continue to listen for streaming responses and error handling, in general. So, but before I run this cell, please note that we need to keep the other notebook where we are actually doing the inference open, and we need to pass the session ID to it, right? So we have to do it, let's say, since I have given a 60-second duration here, meaning the session or this WebSocket connection will get closed after 60 seconds. we have to run this particular notebook within the 16 seconds of running this cell. So I'll first explain what is there in the other notebook. So in this notebook, what we are basically doing is we are using the Inference API, and we are of course using the block ID that I talked about, and we need to paste this particular session ID. So let me, I'll keep it ready. I'll copy and paste it here. So this session ID, I'll run it right now. So this is what I'm explaining here. What is the action required? So once you have this session ID in place, now what we need to do is I'm creating an inference request. So here you can see what I'm doing is basically with this Inference API, I'm creating a payload like this, which contains the block ID, right? That is nothing but the magistral block ID and the session ID, and I'm passing the system message. The system message is just a URL helpful assistant, and the mode is chat, and I'm passing the message that that is called when this function is called, right? So here you can see I'm giving a basic message. It has explain the concept of machine learning in simple terms, right? So before I run this particular streaming inference code, I need to run this asynchronous call, right? So that it will be waiting for the text. So it will listen to that particular WebSocket. So that's what we are doing here. So here we are connecting to the WebSocket URL. They are the Python's WebSockets, and we have certain timeouts, ping interval and all. And here you can see that we are waiting for the messages to be received, and that is what we will display here, right? So let me run this cell, and then I will immediately go back to this particular streaming inference notebook, the inference notebook, to perform the actual inference. So I'll run this now. So this the WebSocket URL is already available as part of the previous cell. Session ID is also available. Yeah, so now it is saying listening for messages for 60 seconds, right? Now it has connected. Now let me run this cell. Yeah, so sending inference request. Now you can see the streaming data is available here, right? So message 1, message 2, message 3 and all. So basically it is streaming now. And it is also internally we are handling, we need to know the termination of a stream, right? So that's why there is a start of stream, end of stream and all. So that also, the whole streaming data is available here. And here you will get the final response only, right? The final response is the machine learning is like teaching a computer to learn from experience. This is the LLM generated response from the magistral model. But sometimes, it is possible that we need to integrate with the UI. So for this reason, we have added this UI facility, right? So here what we are doing is we have a Streamlit app utility kept ready for you. So you can, I'm just importing the model, importing the necessary packages here, the run Streamlit direct, and I'm passing the gRPC server address and the block ID to this, and we will get one URL. With that URL, we need to open the UI and type the query, which I'll demonstrate now. Okay, now let me do a inference. Let me run this code so that we can get a Streamlit UI. Basically, the Streamlit app runs in the background, and we will pass the URL so that we can open the URL and show this demo. So here we are opening the Streamlit chat, right? Let me take the same message. So here we have that Streamlit UI, and if a file is required, we can, if the model supports file reading and all, we can use that as well. So now I'm copy pasting this. What we should see is we should get the model's streaming response. We should not get the final stream, the final generated output. We should get the streaming response. So earlier we got some response here, right? It might have gotten loaded quick, like one by one, but we were checking, we would have been checking a bit late. So what I'm doing is in the UI also you can see that it will do a streaming. So let me run this now. You can see, right, it is adding text one by one, right? So this is the streaming output that we can get from the LLM models, right? So with this command, right, with this code, you can also use the similar Streamlit UI to do chat kind of interface. But there is a small note that I want to tell here. So in the same notebook, we have added a main.py code where you need to understand how this streaming is enabled. So first of all, we have this main.py which contains the WebSocket streaming manager class. So here we are defining this listen for jobs as in the init method, and we have this write WebSocket. So here this is the actual object that is passed to the block code that we write for the model. So we have this inference model, right, where we will have our own custom chat interface or model loading and doing inference part. So that is the place where we will use this write WebSocket command to write the streaming response. So basically, all this is done under the assumption that the model supports the streaming facility, right? So we have this flag in the onData function usually. So in the onData function, if ESWS is made true, right? So we in the onData method we need to use that. We need to check for this flag and then perform the writing of the streaming data. So that's how we can, the AIOS WebSocket and the models WebSocket are, the models streaming capabilities are connected. So again, you can refer to the attached model inference code. So that will have that will give you a whole picture as well. So in summary, in AIOS, you can also use the WebSockets, AIOS WebSockets to do a streaming inference for your LLM models. Thank you. So in summary, in the block code of your model inference, what you have to do is you have to use the ESWS flag, whether it is enabled or not, in your block inference onData method. So if it is enabled, if you are and the model also supports streaming, you can use the context object that you get in the blocks inference code, and also you can switch between whether it's inference, streaming inference or not using this ESWS flag, and you also have to ensure that this particular model inference code, you have to make sure that you write the chunks as and when you get, so that you can pass those chunks to the context.writeWS method. So this will make sure that you will get the streaming response via the WebSocket. So this is how the AIOS WebSocket and your model's inference can be combined to give a inference streaming inference in the UI, right? Thank you.